in this video, we're going to have a 3-step foolproof plan for conquering resonance contributors. Resonance is a historically confusing topic for students. It's one that often gives students a lot of trouble throughout the entire course. We're going to keep coming back to it over and over again. So in this video, we're going to have a 3-step foolproof plan for conquering resonance contributors. Let's get started. When you encounter a new resonance structure, here's what you should do. Step 1, where is the unhappiest place in the molecule? Don't overthink it. Look at the molecule. Where does it look unhappiest? Probably the place with a positive or a negative charge. Here, the unhappiest place would be the lone pair negative charge. Step 2. Is that place unhappy because it has too many electrons or too few electrons? A negative charge is a buildup of electrons. So much excess electron density has a negative charge. So this place is unhappy because it has too many electrons. Third, do we want to move electrons towards or away from that unhappiest place? Well, if the negative charge was unhappy because it had too many electrons, then we shouldn't push any more electrons toward that negative charge. We want to push electrons away from that negative charge. That's it. These are the 3-step foolproof plan for figuring out resonance contributors. Now, the actual how-to of drawing resonance, I'm not going to go over that in this video. I've got a link to that video down below. But these are the steps that we can use to figure out resonance. So let's do it. If this negative charge is the unhappiest place because it has too many electrons, we should push electrons away. Like to where? I can take this lone pair of electrons and I can drop it down to form a new pi bond between carbons 1 and 2. That's going to build up too much electron density around carbon 2, though, so I need to break that pi bond. What can I do with that pi bond? I could continue moving it down the molecule, but here's a pro tip. As you're just getting better at resonance, don't draw any more than 2 arrows at a time. That will save you from skipping over any resonance contributors you're going to miss. So I can break this pi bond, and I can take those electrons and I can localize them locally onto carbon number 3. This is going to be how we can draw this next resonance contributor. Remember, as we're drawing resonance contributors, we can't change the single bonding network of the molecule. So a numbering system often helps. Remember, as we're drawing resonance contributors, the net charge of the molecule cannot change. So the net charge of this molecule, if it started out as net negative, is going to have to stay net negative. So how are we going to draw this next resonance contributor? The negative charge, we took those electrons, we formed a new pi bond between carbons 1 and 2, so there's a new pi bond there. We broke the pi bond between 2 and 3, and we localized those electrons onto carbon 3 as a new lone pair, which means carbon 3 now has a negative charge. I'm not going to go into how we know it's got a negative charge. I've got a different video on charge patterns that you can watch down below. Now, the other question that I always get is, how do I know if I'm done drawing resonance contributors? Well, you go through the same 3-step foolproof plan again. Where's the unhappiest place now? Now it's carbon 3, because carbon 3 has a negative charge. Carbon 3 is unhappy because it has too many electrons. So we need to push electrons away from carbon 3. Like to where? I could push them back towards carbon 1. That's just going to give me the same resonance contributor I had before. Or I can take those electrons and move them to form a new pi bond between carbon 3 and carbon 4. That's going to build up too much electron density around carbon 4. So I'm going to take this pi bond between carbon 4 and carbon 5 and deposit those electrons locally onto carbon 5. That will give me a new resonance contributor. Again, the single bonding network is not allowed to change. So let's go ahead and number our carbons to make sure we don't drop or add any carbons. The carbon pi bond between 1 and 2 hasn't been changed, but I've taken this lone pair and I've formed a new pi bond between 3 and 4 and formed a new lone pair, and therefore negative charge on carbon number 5. 3 steps again. Unhappiest place is carbon number 5 because it has too many electrons. So I need to push electrons away from carbon 5. Like to where? There's nowhere out on carbon 6 that I can draw any more resonance contributors. Carbon 6 has 3 implied hydrogens, so there's no resonance out towards carbon 6. So if I can go back this way, I can make a new pi bond between 4 and 5, but that's going to put a lone pair on carbon 3. So all I'm going to be able to do is go back to previous resonance contributors I've already drawn. This is again why I like to draw no more than 2 curved arrows for any one resonance contributor. This tells me that yes, this is the end of this resonance series. These are the resonance contributors for this molecule. This is how we can use the 3-step foolproof plan to once and for all finally conquer resonance.
Thanks for joining us today, ninjas. Be sure to watch these other videos to level up your ninja training even more. As always, don't forget to like and subscribe.